All right, so picking up where we left off after you were trying these problems here. So, six triglycerides are a type of fat in the bloodstream. The mean level for U.S. adults ages 20 and older is 97 milligrams per deciliter. Assume that triglyceride levels of U.S. adults who are at least 20 years old are normally distributed and a standard deviation of 25 milligrams per deciliter. You randomly select a U.S. adult who is at least 20 years old. What's the probability the person's level is less than 100? Use technology to find the probability, and then draw the normal curve. All right. So let's identify some important things after we draw our initial sketch. Just get that curve looking, and then some important things. They tell us the mean is 97. And then we have a standard deviation of 25. And we want the probability is less than 100. So our mean was 97. Standard deviation is 25. So when we talk about our z-score, and we wanted a score less than 100. Okay, so since we are sketching our shaded area going over our mean, we know it's going to be more than 50% for our percent. And so that gives us a good idea as we take this and get our z-score, and then we'll take that to our table, but that gives us an idea of what we should be expecting. All right, so this then gives us a z-score of 0.06, which we'll then take to the table. All right, so we wanted 0.06. So like we said, we expect to be above 50% and not by much, so 0.5239 checks out. Or 52.39% will give us what is that probability that their levels are less than 100. 7. U.S. adult who's at least 20 years old is selected at random. What is the probability that the person's triglyceride level is between 100 and 150? So we'll draw our sketch. There's our mean, and we wanted between 100 and 150. Well, the nice thing is we found 100 already. So now we just need to find 50, or 150, sorry. So we have z equals 150 minus 97 divided by 25. So we get a z-score of 2.12. We're going to take that to our table. Okay, so 2.12, so 0.9830. So our value of 150 gave us a percent of 9830. And we want the in-between, right? So we're going to take the 150, which is this, plus that amount, and then the 100, which was just this amount. And if we subtract the 100 from the 150, that'll give us the in-between. So 0.9830 minus 0.5239. And so that'll give us an in-between percent of 0.4591 or 45.91%. So the probability of levels being between 100 and 150 is 45.91%. All right, 8. One classic use of the normal distribution is inspired by a letter to Dear Abby, in which a wife claimed to have given birth 308 days after a brief visit from her husband, who was serving in the Navy. The length of pregnancies are normally distributed with a mean of 268 and a standard deviation of 15 days. Given this information, find the probability of a pregnancy lasting 308 days or longer. What would you tell the husband? Mystery ensues. Dun dun dun. All right, so draw our sketch as always first, even in mysteries. And then we have our mean of 268 and our standard deviation of 15. And then our value is 308 or longer. So put our mean on here. We want 308 or more. So then we have our z equals 308 minus the mean of 268 divided by our standard deviation of 15. And so that will give us a z-score of 2.67. So already 2.67 we know becomes pretty high, but let's go take that to the table and find our actual percentage. And we're looking for 2.6 and then 7. All right, so 0.9962. So we get 0.9962, but that, I really should have made this in the red. All right, so that is really this portion, because remember our table always gives us to what's the left. And so also the sketching, when we see there, right, we sketched it and it was just this small portion which did not go across our mean. So our expected percentage value is going to be less than 50. So 99 is way more than 50. So remember, when we want the right side, we're going to go 100 minus the percent or decimal we get from our table. So remember, to find the right side, we're either going to go 1 minus 0.9962, or if you already converted it to a percentage, you can go 100 minus 99.62, giving you a percentage of 0.38. And so the probability of the wife giving birth 308 days or later is less than 1%. Is it likely? Less than 1% likely. I would tell the husband, I think you have a long conversation to be having. All right, so let's take a look at these last couple here that we're supposed to work on. And so context here is we're talking about IQ, intelligence quotient. And so we're told that IQ is normally distributed with a mean of 100 and a standard deviation of 15. And approximately 95% of the population scores an IQ between these two scores. And we have a nice little hint here that that is 2 standard deviations. So real quick as a reminder, right, we had 68, 95, 99.7 rule, or the empirical rule, where 68 was 1 standard deviation and then 95 was 2. So we can work out from there in one method. Our mean was 100, so 1 standard deviation up is 115, 2 standard deviations up is 130, and then we subtract to work our way down. So 1 down is 85, 2 down is 70. So then from this, we could say that 95% of people have an IQ between 70 and 130. Now another way you could do this problem, and this is helpful for ones where it doesn't fall on exactly standard deviations. And so we know at our mean of 100 that to the left of that is 50% of the data. All right, so all of that is 50%, and all of this is also 50%. But I want 95, the middle 95. So from 50%, how far out do I have to get that 95? Well, I'm going to split that 95 in half. which gives me 47.5. So that means going this way, that puts me at 97.5. And then when I go this way, I'm going to subtract, which puts me at 2.5. Well, then those are decimals. So 0.025 and then 0.975, which we can then go to our table and find those corresponding z-scores. So let's go ahead and take a look at that. Okay, so remember inside is our percentages. So I'm looking for initially 0.025. So as I go, and what I do is I track down this first column and then I'll work across once I get there. All right, so there's 0.228 and then I get 0.287 on the next one. So I know it's between those. And as I work, there is our exact one. Sometimes it's not always exact. Sometimes it's going to be in between, and you pick the one that it is closer to. All right, so for argument's sake, let's say we were picking, I had 0.0195. That would be between those two values, but it is closer to that one, and so that is a z-score that we would use working back from there. All right, so we have ours, and so working back from there, we have 0.06 and negative 1.96 would be our z-score for that one. And then we want 0.975, so we're coming all the way down here. Again, working down this first column. And 0.975, so we're in between here, so I'm going to work to the right. And there is our 0.975. As we work back, you might notice something, that the value of our z-score is exactly the same minus the negative. So on these, when you're finding the middle, you only have to find one of the z-scores because the other is just the opposite, which should make sense because we found the middle, right? So we started at 50 and we went the same amount of distance from the middle, which is our mean. And remember, the z-score is just the number of standard deviations away. So if I go up the same amount as I go down, that standard deviation value, z-score value, is going to be the same. One is just negative, denoting you went to the left. All right, so let's take the negative and positive 1.96 back. And now we're going to use this in a different manner. So we know our z-score. So I have negative 1.96 is going to equal our value. We don't know what that is. Still subtracting our mean of 100. And then dividing by our standard deviation, which was 15. And then we do the same for the other side. All right, so on both sides, I'm going to multiply both sides by 15. And that will give us x minus 100 equals a negative 2.94 here. And this will give us x minus 100 equals a positive 29.4 there. And then we add 100 in both cases. And over here, we get an x value of 70.6. And over here, we get an x value of 129.4. Both of those pretty darn close to what we had said here of 70 to 130. All right, let's look at number 10 here. So Mensa is a high IQ society which provides a forum for intellectual exchange among its members. They're members in more than 100 countries around the world. All right, so you're thinking about making a Mensa chapter in your hometown, which has a population of about 10,000 people. You need to know how many people will qualify for Mensa, which requires an IQ of at least 130. And you realize that IQ is normally distributed, as we already saw, with mean of 100 and standard deviation of 15. So using our sketch again, we got 100. We want greater than 130. So z is equal to 130 minus 100 divided by 15, which we know from above is 2 z-scores or 2 standard deviations away. All right, so we'll take our 2 into our table here, and we're going to look for exactly 2. So there's 2, 0. So 0.9772. And then 100 minus that, 97.2, gives us a percentage of 2.28. All right, and so 2.28% of the population will qualify. Well, the question is, what's the approximate number of people? So we're going to take that, and we want 10,000. Or multiply by, we got to go decimal on this one. So there's approximately 228 people that qualify. All right, good. We're going to skip 11. And I want to finish with 13 here. What would be the minimum IQ score needed if you wanted to start an ultra Mensa club that included only the top 1%? So our sketch, there's our 100. I want the top 1%, so I know I'm doing this, and we want 1%. So I don't know what my value is here. That's what we're looking for. So I have a z equals x minus 100 over a standard deviation of 15. So we have 2 unknowns, but we know our percentage. So remember, that's the inside of our table, so we can take that percent to our table and work backwards. So we're looking for 1% here. But as we're looking for 1%, remember we wanted the right side. So if I want the right side of 1%, well, our table gives us the left side. So what we really need to look for is what this left side is here, which is 99%. So we're going to look for 0.99 as best we can. So that's way down here. So it's between these two. So I'm going to work my way to the right now. And again, we had 0.99 falls between those two now. Well, super close, but it is closer by 0.0001 to that one, so we'll use that. So that gives us 2.33. So z is 2.33 equals x minus 100 divided by 15. Go ahead and multiply both sides by 15. Gives us 34.95 equals x minus 100. Add that 100 over, and x equals 134.95. And so if we want the top 1%, we're looking for those who have an IQ of 134.95 or rounding to the nearest integer of 135. All right, there is the applications of z-scores and using our tables going both ways, taking a value to find the probability or percentage of that, then also taking a percentage and working back the other way. Okay, and then you'll have some MyLab practice with this.